Hi, this is GitHub Actions for automated CI/CD deployment to an AWS containerized stack. I'm Adam Culp. You can find me on Twitter at Adam Culp. If you're ever in South Florida, look us up at SoFlo PHP or SoFlo Pi. Those are local user groups that I organize. Also, you can find me on my podcast at Run Geek Radio, and on YouTube, you can find me at Beachcast, where I create tech videos and programming videos. Some of the main pain points that I'd like to talk about in relation to continuous delivery or automated deployment are things that companies and developers experience on a regular basis, such as inconsistent deployments. If you're manually doing deployments, maybe files are forgotten, maybe certain sections of the application end up falling by the wayside. We typically deploy just one or two things that we need versus deploying everything. And it can also make rollbacks very painful. Maybe there was testing that was missed on certain features that are now being pushed. Maybe there's feature lag between environments. Maybe your production is falling behind more than you think it is as far as your deployments go. And it can also add up to longer development cycles. If your deployment is painful, if it takes a lot to deploy to production or any other environment for that matter, anybody would tend to let that lag a little bit, or try to draw it out until there was more deployment to be made, or until things were more complete to deploy them, versus doing it in a much more rapid and a much more agile sort of way. Another thing that you can run into with doing manual deployments and non-automated deployments is lack of tribal knowledge with employee turnover. So if you have, chances are the same people are typically doing the deployments. And when those people are doing their deployments, maybe there's small steps that aren't typically documented that they're just used to doing because they know that it is required in order to do these deployments. And then when that person leaves the company, or if they're on vacation and somebody else needs to deploy, then that information is lost, and maybe the deployment doesn't go as well as other deployments in the past. Some of the benefits, of course, of automated deployment is that in terms of development environments, when you have developers, or you're onboarding a new developer, or if old developers have rendered their current development environment not very usable, it's very easy with automated deployments, using a single click in most cases, to create a new development environment. And be able to rebuild in development environments, or create new and development environments for new employees. Through the automated process, we can also automate the build steps, the testing, and everything based on commits. So when a commit is done, create a build and run the tests, and then we can get logs and feedback of what happened during that process. And you find that it's also more consistent across environments. So your development, your testing or staging, and then your production typically tend to be a lot more consistent across the various environments, because it's all automated. It's doing the same thing in each of the environments, and it's repeatable over and over again without having to worry about missteps. And another nice thing is you can externalize the configurations. So you don't have to worry about configurations being included in your code, which they shouldn't be. You can have all that externalized. So as your push is happening to a certain environment, it can pull the configuration that is appropriate for that environment, whether it's dev, testing, staging, or production. And those are all externalized. They're kept in some sort of a secrets manager, or some sort of place where it doesn't have to be in the code, and everybody, all the developers, don't know all the secrets for production, or so forth. And the nice thing is it's infrastructure as code. Because you're automating the process, everything is contained within the code. You have your infrastructure all there. It's able to be viewed by anybody, audited, and you can version it. So as new things are done in your environments to automate the process, It's totally viewable right there, even testable. And the nice thing is you can automate the triggers all the way up to production. So whenever you're doing code commits, or whenever you're creating new tags, or whenever you're creating new versions, that can all be automated. So when the action happens, it just pushes to wherever it needs to push. So as just a little bit of business statistics that I found very interesting in relation to DevOps and relation to this automation, 86% of organizations say that speed is vital to their application. It's vital to their business. 86% says that it's vital to be fast and be able to do things in a faster way. However, only 77% of companies are actually using DevOps, are actually using ways of automating things, according to some statistics. Now, out of that 77% that say they're using it, only 10% say that they're successful at it. So there's still a lot of ground to make up there, whether it's better tooling, or whether it's just making it more training, or making it easier for them to use. We really need to work on that 10%. And out of all the companies that are doing it, 49% cite that legacy applications, legacy code, legacy processes are the biggest challenge to adopting DevOps practices. And that kind of goes hand in hand with, we still need to build more tooling to help with those sorts of things, to help take some of the challenge out of legacy. Out of those who have adopted DevOps, 71% say that they're using containers. That doesn't mean they're using only containers, but it does mean that they're using containers of some fashion as part of their DevOps strategy. Some example businesses that are using DevOps or using deployment. Capital One deploys 50 times per day. Meanwhile, Amazon, Google, Netflix, they're deploying up to thousands of times per day. And Etsy, of course, back in 2014, released statistics that said that they're doing about 50 times per day there. So there would be no way that these companies would be able to deploy at that scale without automating it, without making it in some sort of fashion or some sort of way that would facilitate them being able to do this in an automated fashion. One of the ways more recently that developers and companies are starting to look at is using GitHub Actions. GitHub Actions is relatively new, and it's just a way to automate your workflows from idea to production, is what it says on their site. And the nice thing is it's all right there within your repository. I like the ease of use of it. So if my project is on GitHub, Actions is just one part of the repo, right there within GitHub. So it's very easy to use because it's automated. It's easy to automate. It's infrastructure as code as well. As I kind of spoke a little bit earlier about how important infrastructure as code could be. The nice thing is these GitHub Actions runs based on the code that is created, the configuration of the workflow that is created in the individual repo. So it's easy to automate using those processes. And there's also other pieces that I'll show you here in just a couple minutes. It's also project-based. So your configurations for the GitHub action are within the project, within the repo. So it's not like you have to worry about, okay, I have multiple files or multiple processes here. Which one is it attributed to? It's attributed to the repo that it's in, the workflow is in. There's also a very handy marketplace within GitHub Actions. So if you're worried about getting started, I know back when I first tried GitHub Actions, there wasn't really a robust marketplace there. It was just kind of experimental, I think, at that point. And it was kind of hard to get working, kind of hard to get started with it. But now there's a whole marketplace, a big, robust marketplace where companies and individual developers have shared their workflows and ways to get you up and working quickly. So chances are there's already something there related to what you would like to do from GitHub Actions to automate your processes. It's probably already there. GitHub Actions have become vital when it comes to building your applications or building the environment as it's going, testing it, and also doing the actual deployment, because it connects out to so many different other things. It just makes it really easy to use. It comes in very handy doing automating processes and your workflows, like doing code reviews, branching strategies, also handling issues from within GitHub. And all of those things could be handled easily using GitHub Actions. Now, in this talk specifically, the example that I'm going to show and walk through is using Amazon ECS, or Elastic Container Service. So let's talk a little bit about Elastic Container Service and what is it. It is a way to be able to manage containers on Amazon and deploy code into them and make applications use containers directly on there. So Elastic Container Service is Amazon's flavor of being able to do, handle containerized services. The nice thing about it is, just like most things at Amazon, security is job zero. So they've really put security into ECS and made it easy to do. Not only is the infrastructure immensely secure, you can also use other things, other services within AWS, such as IAM, to add security and rules and things like that to the process. It's fully managed. The nice thing is that you don't have to worry about managing the infrastructure behind the containers and all that there. Amazon manages all that for you. So all you need to do is be able to use the containers and scale them, do whatever you want, script them out, anything, but then let Amazon handle the back end of it all. It is a container orchestration service, so that is what it's centralized to. It's working with containers, and it really helps orchestrate that service so that way you don't have to do all the heavy lifting of it. It makes it very, very easy to use, and it integrates with most other AWS services. As I said before, if you wanted to use permissions, IAM, things like that, or S3, all these things, you can use those with your containers on ECS, and it really integrates well with a lot of different other places built on AWS. It also leverages serverless. If you've done any serverless on Amazon already, and chances are you have, that's why you're here. It leverages Fargate. So if you're already kind of familiar with Fargate, maybe, ECS leverages Fargate for its serverless, and it really makes it quick and easy to rapidly deploy and scale. So if you want to rapidly deploy something, ECS is very fast as far as doing your building and your deploying, and it scales. You can scale it so well. To facilitate, getting your applications out there and ramping them up when you need to, or tear them down if you don't need to. So another service that I'm going to talk about a little bit here is Amazon CDK. Amazon CDK is the Cloud Development Kit. Now, the Cloud Development Kit is basically the core of infrastructure as code. It's just a way of creating code that creates and ramps up your infrastructure in this case. Some of the points of it is, one, it's open source. It's available out on GitHub. You can find the source for it. It's also infrastructure as code, as I said. So all your code is going to be in your repo. Now, the neat thing is with most provisioning services, you're going to be using their configuration files or what have you. CDK is a little different. CDK is it's a development kit that you are able to build on using the programming language of your choice. So if you're using JavaScript or TypeScript or Python, Java, C#, and as of recently, Go. So if you're using any of those programming languages, and that's where your expertise is, you can create CDK scripts using those programming languages, and that's exactly what you do. You're making the calls from the programming rather than having to use something else. You're using the programming language that you are most comfortable with to do this. The nice thing is because you're creating the code directly in your repos, related to your project, it's versioned. You're versioning it in your source control. So as you make changes, as you add new things, or as you change things, you're versioning it in your source control. It's also testable because it's the programming language of your choice. And if you already got tests, you can just continue right on testing as you're used to. And there's also a nice handy CLI that comes with CDK that enables you through CLI to be able to address, access certain portions, certain commands with it. But the big thing is it's you've got many languages support. And if there are any other languages that you would like it to support, there's in the repo, and I'll link to it later, but in the repo, you can actually request your programming language be added as one of the supported languages. I recently tweeted out and brought it to folks' attention that PHP was not in this list. So we requested that, and a few other people are also +1ing it. So if you want PHP to be one of the supported languages, go out to the repo and by all means +1 that as well. Another service that I'm going to be using in this example is Amazon Code Build. Now, all these things that I'm talking about are all part of the infrastructure that is available to automate deployments, automated building, creating builds and doing all these things. Amazon Code Build is one of those. It is part of the code pipeline. But the code build portion is being used in this example to build the package that is then going to be deployed to CDK. So we're going to use Code Build for that. So some of the points about Code Build is it compiles source code and gets it all ready to go out and deploy somewhere. It can also be set to run your tests. So that way all your tests are being ran as part of the build process. And it produces software packages at the end of it. So, at the end, you got a zip file or an archive that is ready to go somewhere, ready to be deployed. The nice thing is it's scalable. As your applications grow, or as you have more applications, it's really scalable. You can create multiple builds concurrently from within the application. So you can create as many builds as you need to and have them running concurrently. For in the case of some bigger projects. And it's really customizable. You can completely customize every bit and piece of your deployment as it's being carried out. And as you're creating the code to let Code Build know what you need to have done. And then, of course, we're going to be using the GitHub Actions workflow. Now, as I said earlier, the GitHub Actions are part of the repo. In this screenshot, it's not important if you can't see it, but it is just a repo that I created out there, a little sample code repo. And Actions is just one of the tabs. And when you click on that, you can see that there's a marketplace right at your fingertips, or you can just click the link to set up a workflow yourself. And you do that all through the interface. And when you do that, it creates a file for you in your repo. Because again, it's repo specific. Now, in this case, what I did is I used the marketplace, and I'm leveraging an Amazon Action workflow template that is created by AWS. AWS has created a few and put them out there. Amazon has put a few out there. The one that I used for this example is deploy to Amazon ECS. It made it really easy to get going because the template had all the beginnings that I needed there. So I was able to use that straight from the marketplace. And there's a lot of things out there. Chances are, if you want to do anything using GitHub Actions, there's probably a beginning template created by a company or an individual out there for you to use. So in this case, I used that deploy to Amazon ECS. And now, again, what it does is as you use those templates or as you create your file, in your code base, in your repository, you're going to have a .github directory. And inside that .github directory, there's going to be a workflows subdirectory. And that's where you'll keep your workflows. In this case, in the example you can see on the screen here, I have aws.yml, and that is basically the Amazon deploy to ECS workflow that I used. It created the file right there. It's part of my repo. It's versioned along with all my other code. and everything was contained inside that file. So the file starts out with something like on push, and you can see here that every time that there's a push request to this repo, to the main branch, then it's going to execute this action. And the action itself is, calling it deploy, and it's going to run on Ubuntu's latest, and the environment, of course, is production in this case. So that's just the beginnings of the file. The file goes on because after you get this initial set done, further down in the file, then you start defining steps. And in my case, steps were like check out the code. The second step is configure AWS credentials. Following the configure AWS credentials, then the next step is log into Amazon ECR. So again, you define all these steps as you go, and you define all the bits and pieces of it. You can also have it leverage Secrets Manager in AWS, which I'm doing for my secrets. And you can see that on lines 46 and 47 here in this snippet, where I'm calling secrets to get my AWS access key, or an secret access key, or AWS secret access key. So I'm getting all of that from Secrets Manager. It just makes it easy, secure to use. I don't have to worry about putting credentials into Codebase or anything like that. It's all done in this way. Now, one of the items that need to also be part of my repo is a task definition. So all this process is being executed, there's a task definition that is very important because it uses it in order to say, okay, how does the task need to go? And it's more than just the steps of saying to execute it. It's deeper than that. In this case, we can see that in this example, we can see that it's using it's creating the name and it's creating the container. So the task definition is related directly to ECS. So as it's creating ECS, this task definition is what drives it. And also any port mappings, for instance, or things along that line, what image to use to create the containers. And that's all contained in the task definition. I'm not going to go into too much depth here. You can look at the sample code if you wanted to see more in depth what it's doing, or go out to GitHub Actions yourself and look at the workflows that Amazon provides the templates for. So then after everything's all executed, then and the GitHub action executes the workflow on push requests. Then it creates all that, uses Code Build to create the package, and then it comes out and you can see the Code Build job is here. You can see that it succeeded because it did succeed. The social saver application that I messed with, is here as now a Code Build step. There's multiple steps to follow in Code Build. I'm not going to go into depth on them here. I only have so much time in this talk, but it's really easy to follow along, and it's highly customizable. So it can be a little bit daunting to look at it. There's a lot of settings that somebody might possibly want to do with Code Build. But that being said, it is completely customizable for you. And I'm going to link to a blog post at the end of this presentation. I'll show you, where you can go to see a sample of all these things, a sample of all the code, and also an example blog post kind of walking you through learning some of these new things. Now, we're not doing a lot with Code Build here as far as the overall application goes. It's just building the package to deploy and also running tests if there's any tests. Now, the end result, of course, is once Code Build runs, is then we have an ECS cluster. We have an ECS cluster. In this case, there's only one service in the cluster. And it's being created, and it's right out here. And then all the details that were put into Code Build, all the details that were put in the task definition have all been executed to create this cluster. And so it's there ready to run. And you can see there's also Amazon EKS. So if you wanted to use Kubernetes instead of Amazon's flavor of Elastic Container, you could do that here. ECS, I find ECS a little bit easier to use, a little bit more flexible. Now, then back at GitHub, once all that has been executed, GitHub is waiting for the result. So after everything's been executed, GitHub Workflows is sitting here waiting for the result. And you can see that we got green check marks here. So it did actually run the workflows, created everything for us. And according to what we specified. So we're getting a green checkbox back here. And you can click in, you can see the details of it, as well as clicking into any of the AWS services and being able to see the details there. The logging is just phenomenal. I really enjoy using the logging and being able to go in and see, each individual step. There's just not enough time here to go into depth on it. I have created some more resources for you. So on this resources here, there's a link to GitHub Actions out on GitHub. There's also a link to ECS, Amazon Elastic Container Service, Amazon Cloud Development Kit, Code Build, and also a link to the sample code that I told you about, where I created it on my personal GitHub at Adam Culp, social-saver. You can go out and you can see how I created everything and in order to execute the test. And you can run it on your local, or not your local, you can run it on your Amazon AWS account as well. And have some fun with it. Now, there's also a couple other links here, helpful content. The first one is actually a link to a blog post by a friend of mine, Bryant Bost, over at AWS. He created the blog post of basically how to use all these services and do exactly what I just showed you here at a very high level. But he goes in a lot more depth in his blog post to help walk through step by step. So I basically did that to create Social Saver as an example. And so if you want to check out that blog post, it's really helpful, really, really useful. And then there's also on Amazon support, they created an ECS Fargate static elastic IP address that can kind of give some insight into how to assign IP addresses to these containers and so forth. Typically, though, what you're going to want to do is you're going to want to, along with creating the ECS container as part of your build process, you're going to want to also build an elastic load balancer or something along that line. So that way, if you wanted to serve up a web application, you can use Elastic Load Balancer to do that for you and be able to make it publicly accessible or not publicly accessible, as the case may be, depending on what you need for your application that you're putting on ECS. Some additional things that I also created in here were some resources. I shared a lot of statistics and a lot of information earlier in this presentation, and here are some added resources or added sources of where I got that information from. If you wanted to read a little bit more about some of the statistics of companies that are using DevOps, using automation, and what they've found that works for them or doesn't work for them, as the case may be. That's all I have. I hope you found this really useful. If you have any questions, please feel free to ping me on Twitter. And I'm going to be sticking around here for a little bit after this talk to answer questions as well.
That was awesome. And we are about to be joined, and there he is, Adam Culp.
Hey, you able to hear me okay?
I can hear you just fine. Hopefully you can hear me. And
awesome, I can. Yeah.
Awesome. Well, thank you so much for being part of GitCon. I was very excited when you agreed to do this talk with us. And we have, about 15 minutes or so to answer questions. And thank you very much for hanging out in the Discord and for directly answering folks out there. But for the benefit of everyone that's not on Discord that hasn't seen what you're talking about out there, it's more of first off, say, there you are for folks that are wondering about your title. I'm going to flip you over to this side of the screen. A little bit of housekeeping there. Got to love a live conference, man. Yeah. So the first one really wasn't a question, but I would love to just hear your insight. You mentioned it in the talk, and Matt out there caught it. Matthew caught that, but site legacy is a challenge. I guess 50% don't want to admit it. You've worked at some very large organizations in your life. I would just love to hear you expound on that comment a little bit.
I've worked with probably about half of the Fortune 100 companies out there and helping them refactor code and modernize applications and modernize stacks and what have you. And I mean, those numbers, although the numbers are statistics that I'm sharing from another post that I shared at the end as sources, I found much the same thing in my day-to-day consulting with these large corporations. And that is that legacy code can really hinder them. It can really hold them back from automating these processes. If your stack is built in such a way that you really have to jump through hoops to get an environment up and working, obviously you're not going to be able to automate that really easily. And so it's definitely a hurdle that a lot of companies face, where they're just not able to automate, or not able to automate easily without first going through the modernization practices, make sure their application is even able to be cloud ready. And to facilitate that, and that's important. A lot of folks overlook that piece. They think, oh, I just create an application, I'm going to throw it out on the cloud. Well, sometimes that works, but sometimes it doesn't. Sometimes you have to put some forethought into your application to make it ready to be on the cloud. Now, that's not to say you can't throw something out in a container or some type of cloud hosting. You certainly can. But if you really want to embrace the cloud, if you really want to embrace CI/CD, a little bit more thought needs to go into that.
Right on. Really appreciate the comment there. Clicked the wrong one. Also, since by Matthew out there, the industry moves toward all these new tools that embrace built-in declarative documentation by design. How is it transforming organizations, best practices, and knowledge transfer?
Wow, that's a big question.
Yeah,
That's a very big question. I wasn't ready for that question, but let me see if I can break that down a little bit. So I think that's, much like I said in my previous answer, it's really going to take some preparation. It's going to take some forethought into, what you want to do. It's really difficult for developers and companies who don't put that forethought in and don't design things ahead of time, at least on paper, or at least in some sort of diagrams and things like that. So I really encourage folks to, before you jump in and expect to be able to create something that is production ready, be prepared to spend a little bit of time ahead of time, just planning a little bit, and at least knowing a little bit more of what you want to do, and get your requirements in place and things like that. It's infinitely important to make sure that we are planning ahead of time. And that's kind of a difference that you run into between, entry-level developers, even mid-level developers, as they progress through their career up into an architecture type of level. That is one of the main differences that I see, is doing that planning, doing that construction, and getting it ready. So I often, developers often ask me, what can I do to become a senior level developer or an architect level developer? That's about it. I mean, that's not the only thing, but that's one of the main things, is to spend a little bit more time planning ahead of time versus just, starting to write code.
Right on, man. Thank you very, very much. All right, next up, we have from Kartik Gupta. Sorry if I'm mispronouncing your name there, out on Discord. You mentioned that there's an advantage of infrastructure as code, is that these configurations are testable. How would these external tools provide ways to test these configurations?
That's really going to come down to the language itself, because each language is a little bit different as far as testability goes, and what you would use to test. So I can't really break down the tools too much on that. But that being said, in this example, I was showing CDK, which CDK, you're using the programming language that you're already developing in. So if you're a Python developer, you're going to use the Python port of CDK. If you're using, C#, same thing, Java, what have you, you're going to be writing this infrastructure as code in your chosen language. And therefore, it can certainly be testable. You can test and you can verify that it actually does what you're expecting it to do. Be able to do some functional programming ahead of time in a staging environment to make sure that it's provisioning what you expect it to provision. There's a fair amount of trade-off. You'll probably have to plan it, because In some cases, you have to provision it in order to test that it was provisioned. So just know that you'll have a separate environment for that sort of thing versus impacting the same production accounts that you would use for production.
Absolutely, the testing as close as you can to production, and that's one of the advantages to infrastructure as code in the very first place. Like if we can abstract out all of those settings, then it comes down to what I think we were talking about before in between sessions, these last sessions, abstracting away as much as we can to automate, and instead of having to manually trust, as you said, tribal knowledge to get to that same state. I'm just curious, a follow up on that. Do you see any big trends in like trying to unify tools around this testing?
I think each language, each ecosystem has their own consolidations that are happening. I can't really speak to any one in particular. I mean, I do a lot of PHP and a lot of Python, so I can certainly speak to those individually. But I think that each one has their own sweet spot. I mean, in PHP, for instance, there's kind of a change going on. I mean, we've had PHP unit has been de facto unit testing for many, many years. But now there's a new player in the market and called Pest PHP, which is really doing some amazing things. I really like it. Now, oddly enough, it's using actually PHP unit behind the scenes, so it's kind of a wrapper, a more friendly interface to PHP unit, but still really amazing to use. And Python, you have your testing frameworks. Every language has its own. So I can't really speak to that. Now, I would say, though, that as I go from language to language, whether it's C#, Python, PHP, all those, they're all very similar in the way that the testing works. With Java, you got JUnit and some other things there, but they all seem to be kind of similar because testing is testing of object-oriented programming.
Right on, man. Thank you very, very much, Adam. All right, we got next question here. Make sure I hit the right button this time. And this is kind of a big question, and I think there's a few questions in here on, are there any limits to what you can do in a GitHub action? And I think to like further that, and my immediate follow-up question on that, which you can answer both, is there anything you shouldn't do with a GitHub action? Is there any point in the testing where like a human involvement is just going to be a better, like a manual step is the better solution there? I know it's a big question, but I'll turn it over to you.
It is. It's a very good question. So I've actually not found a limitation, but that doesn't mean that there isn't one. But that being said, I've used it for so many things. Even something as simple as if you go to my GitHub profile, github.com/Adam Culp, and you see that landing page there, I actually have a GitHub action behind that pulls down the videos from my YouTube channel and also the podcasts from my podcast channel, and actually dynamically dumps those in there, and it updates on an hourly basis in case I put a new video up or a new podcast. It could be something as simple as that, or it could be something as complex as, like I showed in this example, which is rolling out a complete environment onto ECS using Code Build. I haven't heard of anybody speaking up and saying, I'm just not able to use GitHub Actions for this. Though I'm sure somebody could probably nail it if they needed to. But I just haven't heard that. Now, some things you shouldn't do in GitHub Actions, though, I don't know that I'd want to delve there. I don't do it often enough that I would feel authoritative on that. I would say, though, as far as where I think folks would have troubles with it is kind of going back to an earlier comment, and that is with some legacy applications that really need to be modernized themselves, you might run into situations where it's just hard to automate. But that being said, I'm sure you could use GitHub Actions for something. I do a lot of automation. I would say that probably out of my applications, and even within my applications, multiple places within the applications, I automate pretty much everything. I automate account creation if somebody's doing something on the site, I generally automate that to, offload it onto a Lambda function or something like that. So it handles the processing versus making the end user wait on a web page. GitHub Actions can be used for many different things related to a repo for deployment and automating processes. Like I said, the video listing on my main page in GitHub, that updating every hour is just as simple as going out and hitting an RSS feed and creating links. So there's a lot of things you can really do with it. I think the imagination is the limit.
This actually reminds me of a subject that came up in an earlier conversation outside of GitCon with one of the ambassadors for GitKraken, who wrote a really good article, Everin Tan, talking about the differences between automated or continuous delivery versus continuous deployment.
Mm-hmm.
And where do you see that line of, like, at what point do you want to have a human say, yes, let's push the button, versus the robot just does it?
I never want a human to hit the button. Now, that being said, again, I've worked with many large companies and small companies, and I've been in situations where the companies just don't feel comfortable with that. They're like, wait a minute, I don't want that to be automated quite yet. I want to hit the button to actually do it. And I would say it's just it's kind of it's a comfort that has to be gained. And you only gain the comfort by building good processes. And through building good processes, little by little, you start to feel more comfortable with it. I've found that the individuals or the companies who felt uncomfortable with automating that process and trusting it to go to production or whatever the case might be, those are the companies that are just now on the learning stage of being able to say, okay, well, I feel comfortable with what I just did. I feel comfortable with what's being done. And it comes down to many things. First off, have good testing in place. If you're doing object-oriented, have your unit tests in place. If you're running APIs, have your functional tests in place. So that way you're testing your API and you know what's going on. Now, in this case, one of the things that you can do, and it makes it really easy using containers, whether it's on AWS or what have you. So if you have multiple containers, you can run your deployment and have your deployment only go out to certain containers, have it only go out to a couple instead of all of them. And then after it's there, you just kind of watch for errors. And if you don't see any errors, if everything seems to be continuing as normal, your traffic flows don't seem to be altering in whatever way, then you can say, okay, now let me go ahead and push it out to the rest of them. So you can do some sort of staged approach like that. Many companies work that way, where even companies that have thousands of servers or thousands of cloud instances out there, they push out to a certain percentage of them, watch for errors, watch for any issues, bandwidth changes, what have you. And then as long as they don't see anything, then the rest of them just it trickles down into the rest of the instances. And that works out really well. So that can help breed some of that comfort. But I would say that, we should strive to make it completely automated, take the humans out of the loop. If your code is tested, if QA has passed it, quality engineering has gone through and made sure that everything's good, you've gone through all the workflows that you put in place ahead of time, going from development to testing, staging, and production, then you shouldn't fear going to production. And worst case scenario is, if it goes to production and then you notice some sort of an issue, have a fallback. Please don't have just a way of deploying to production without a way of rolling back. You should be able to roll back within seconds of going to production. And if you don't have that, then you're not ready to go past that, putting your finger on the button. But it's infinitely important to have that. It's more important to have the rollback than it is the deployment itself, because you want to be able to go back and so everything can be reverted back.
All right, on. I hear there's a pretty good version control system these days that will help you roll code back if in an emergency.
Well, to that though, I would say don't use version control for rolling back. I'd say don't do that. I would say, typically what we do is we create a second production environment and change your pointers on your load balancer or whatever to go to the new environment. And then when it comes time to fall back, all you have to do is repoint it. You're not re-provisioning a system to roll back. I would say definitely do that. And
I've heard that called blue-green deployment before.
That's one way of calling it. That's a good name for it. But yeah, you definitely want to have something along that line where you don't want to tear down your systems. You just want to repoint them until you're sure that everything's good.
So two last quick things before we let you go. Apologies out there to Alex Dejanew, who's the actual blog author of our it was an article about GitLab CI on the GitKraken blog, that he's the one that actually brought up the difference between deployment versus continuous deployment versus continuous delivery.
I see that. I'm going to check that out myself.
And then the last one, there's a little softball for you to go out on. How many elephants do you got?
Oh, elephants. I've got quite a few, and they're actually lining my window here beside me, beside the beach, because I live on the beach. So so all in all, I've got 40 small ones. I might be 41. I think somebody just sent me one recently, so I might have 41. And the large ones that I've gotten for keynoting different events or organizing different events, I've got 10 of those.
Wow. I don't know for a fact it's the world's largest collection of PHP elephants, but
I think there's probably a couple people who rival that, but it's pretty darn good because I would say that I've got a couple prototypes up there behind me that we never actually put out. So I've got I see, I'm looking above myself in the camera there. I actually see two that are just prototypes because we had the prototype created, but I didn't actually have them created.
Well, thank you so much for being here, Adam. Thank you so much for the time answering our questions and for hanging out in Discord. And we hope you stick around for the rest of GitCon. We'll wave goodbye to you now.
Yep, thanks. It was awesome. If anybody has any additional questions, please reach out on Twitter. I'll stick in Discord for a while as well. And always happy to answer questions and help folks.
Right on. Thank you.